Alright, so we've got 2 videos left to go. This one is about section 7.2, solving by substitution. I want to remind you that no matter what we do in chapter 7, we're always going to have 3 possible answers. We're going to have a situation where our 2 lines intersect, and when that happens, the point where they intersect, that ordered pair x, y, is going to be our solution. Now it could be possible that our 2 lines never intersect. That means they're parallel. Remember, parallel lines, because they never intersect, and I'm going to draw them parallel like this time, then our solution is going to be an empty set. There's no common point. And the third situation that we can always have in this chapter is that our 2 lines are the exact same line. Well, if I could draw them the same. One right on top of another. And when that happens, all of their points are in common. So we say that there are infinitely many solutions. So there could be one solution, no solutions, or infinitely many solutions. Now today's job is going to be solving, instead of by graphing, by substitution. The steps to substitution are pretty basic. The first thing we need to do is solve so that we either have one variable equal to a number or equal to an expression. Set one equation so that x equals or y equals a number or an expression. Look at problems 1, 2, and 3. Notice that they took that first equation, and in number 1, x is equal to a number. Number 2, y is equal to a number. In number 3, y is equal to an expression. I think in number 4, in number 4, notice they used the second equation, and they made y equal to an expression. In number 5, we're going to make a change so that we can. And number 6, we're going to talk about. So let's go back up here to our steps. So our steps say set one equation so that x equals or y equals a number or an expression. Most often we're going to have an expression, but occasionally we might get lucky and that step 1 will be x equals a number or y equals a number. Not very often though. Step 2 is actually the substitution step. So you're going to plug in that number or expression in the other equation. Plug in that number or expression in the other equation. And step 3 is your solve step. So solve. So that means get both x and y, or get your empty set, or infinitely many solutions. So let's go through number 1. Step 1, do I have one of the equations where x is equal to a number or an expression? Yes. So we're going to make that our substitution step. So we're going to go into the other equation, so go into the second one, and every time we see an x, take it out and put the 7 in. So take the x out and put a 7 in. Everything else in the equation stays the same. Now this 7, the reason it's in parentheses is because sometimes we might have to distribute, or we might have to combine like terms or something along those lines. So remember that in this case, the 7's parentheses are kind of pointless. So we're going to go ahead and subtract 7 from both sides because we're trying to solve for y. It makes a 0, so that we get 3y is equal to 11. Divide both sides by 3. I did subtract properly, didn't I? Yes. So then I get y is equal to 11/3. Remember that if I get y equal to a number, that means that I also have to have x equal to a number. Usually, we're going to take that y value back up and have to plug it in, but we already knew what x was because this was an extra specially easy problem. So our ordered pair is x is 7 when y is equal to 11/3. We have one solution. Those two lines, that vertical line and that sloped line, cross at the point 7 and 11/3. Let's do another one, number 2. This time they've given us y equals a number. So we take that value. Here's the substitution. You go into the second equation, and every time you see a y, you take the y out and put the 11 in. So we're going to do 4x minus, not y comes out and 11 goes in, is equal to negative 15. So that's a substitution. We took the y out and put the 11 in. We finish it up. Again, this is a situation where those parentheses don't do us much good. It's minus 11, so we undo minus 11 with adding 11. They're inverse operations. We end up with 4x is equal to negative 4. Divide. X is equal to negative 1. Remember, if I get x equals negative 1, that means that I have to have a y value. In this case, there's no work to find it. When x is negative 1, y is positive 11, and that's my one solution. This horizontal line and this sloped line cross at the point negative 1, 11. Problem number 3 is the first time that we're going to see a situation where our y is equal to a quantity instead of a number. So now our parentheses are going to become very important to us because we may have to distribute. We're going to do the exact same thing we've been doing. We know that y is equal to this quantity. So we're going into the second equation, and every time we see a y, it's going to come out and the quantity is going to go in. So we start at the beginning here. It starts with 2x plus y. We don't want y, we want this quantity. 2x minus 1, we finish, is equal to 3. This positive is distributing a positive 1, so I'm just going to rewrite it. 2x plus 2x minus 1 is equal to 3. And now I'm going to combine like terms and solve. 2x plus 2x are on the same side of the balance line, so that means we have 4x's over here equal to 3. Now we go ahead and solve, add 1 to both sides. Divide by 4. And we get x is equal to 1. That is not enough information for Chapter 7. X equal to 1 isn't enough. Remember, our answers have to be either an ordered pair, an empty set, or an infinitely many. So once we have that x value, we need to find our y value. So we take our x value back to the top, and we plug it in. It doesn't matter where you plug it in. I suggest pick the easy one. This one says y equals 2x minus 1. We said that x was 1, so y equals 2 times 1 minus 1. So the y value is 2 minus 1, which means that the y value is really a 1. So that the ordered pair in this case is the point 1, 1. Now we have two sloped lines, and they meet at the point 1, 1. I have a feeling number 4 might be a special case, but why don't you go ahead and get it started on your own? So push pause and see how far you can go with your substitution. Hopefully you really did try this, but this time we're going to use our second equation and substitute this quantity into the first equation. Negative 5x plus 3 times y comes out and the quantity goes in. 10x minus 8 is equal to 51. This one definitely has a distributive property. Use your balance line if you need to. So again, we get to the bottom and we've got x equal to 3. That is not enough of an answer for chapter 7. Once you have your x value, you need to take it back to the top and plug it into one of your equations. I still recommend that you pick the easy one. Can we scroll down just a little bit? That would be nice. Guess not. So we have y equals 10 times the x value, then subtract 8. So y is equal to 30 minus 8, which is 22. So that our answer has an x value of 3 and a y value of 22. So we get our ordered pair. Now, when we get to problem number 5, the first thing I hope you see about this is that when we look at the first equation, it's not x equals or y equals. And the second equation is not x equals or y equals. I have a feeling this video is starting to run a little long, so I'm going to start with that in the next video.